Okay, so scalar multiplication. That's when we're just going to take a number, just a regular number, and multiply it times a vector. So let's say you have a vector v, and the position vector is a comma b. Then you're going to take some number times, say some k, times the vector v. Now, I probably really need the notation here to distinguish between just a number. This is just like a real number here, 5. It's not a vector, okay? So, and then we have the vector that we're multiplying it by. That's going to equal, and you might suspect this, ka comma kv. So you just take the scalar, the number, the real number you're multiplying by, and you multiply it by the components, okay? The a and the b. What it means as a picture, let's say you have a vector, like this, and you call this u, and then you want to find 3u. Well, then what you're doing is you're adding another vector u, should look the same size, but I'm not drawing very good, and then another one. You'd have 3 of them, right? Like a u and a u. That's what multiplication is, right? It's like you have 3 vector u's all lined up tip to tail. And you get this resultant vector from here all the way up. So it got to be a really long vector, okay? Because it was 3 of those vectors added tip to tail. Okay, so that's scalar multiplication. We do have vector multiplication. I don't think we're going to get to it this semester, though. Okay, so let's say we have the vector v is 3, 1. So that's position vector 3, 1, and it's right there. And so we can say, when we want to find 3v, that's going to equal 3 times 3 comma 1, which is going to be the vector 9 comma 3. Now my graph paper is too small, but pretend like it was larger. And then you're going out here 3, and then 3 more, and then 3 more, and up to 3. So it'd be like from here to here. That would be like 3v. Okay? All right. Now, what if you wanted to find 1/2 v? Well, the fact that it's a fraction, that's not going to be too exciting here. You're just going to take and multiply those by 1/2. So you're going to get 3/2 and 1/2. Okay? So this would be the vector 1/2 v. And then what would it look like? Well, you would only go out 1 1/2 and then up 1/2. So it's going to be like the vector's just kind of little there. It's like the orange vector was cut in half. Now, what if you want to go in the opposite direction? So the opposite of v, we already talked about that, but it's going to be the opposite of 3 and the opposite of 1. So think about that vector, the opposite of 3 and the opposite of 1. So picture your orange vector, if you can still see it, and now it's going in the other direction, like it did a 180. The vector's going in a different direction, okay? Same magnitude, different direction. Okay, that's scalar multiplication.